Hello, everyone. In this recording, I wish to go over a couple more questions in the homework set number 10 on implicit differentiation. Okay, and some of the questions include number 15, number 17, and 19. And I try to control the whole time within 30 minutes. Otherwise, if we have more time, I will go over one of these, 13 or 11. Okay, so let's start with number 15. 15, we have, the question we have is e raised to the power of x over y, which equals to x minus y. Making the font larger. Okay, of course, what's wanted is dy dx. We're going to view, y is a function of x, and we're going to take a derivative of this given equation on both sides. Okay, so the derivative on the left-hand side and derivative on the right side. And on the right side, we can apply the difference, right? The derivative of difference. So we got this. On the right-hand side, actually, it's pretty straightforward. Okay, the right side, we're gonna get 1 subtracting dy dx already, right? So that's dy dx. On the left-hand side, however, we're going to apply chain rule and then quotient rule. Okay, so derivative of e to the power u, e to the power u, du, and then derivative of u with respect to dx. Okay, obviously u is x over y. Okay, so that's left, and the other one is right. Do we need a parentheses? I don't think so. We don't really need a parentheses, okay? And so now, this step actually you can skip, okay? You can go directly to the next step, which is derivative e to the power u with respect to u is e to the power u, right? And u obviously is 1 over x, x over y. And then we multiply then the quotient, right? So you can actually go directly by, you could skip this step and go directly to the next one, okay? When we apply quotient, we will get, we're going to differentiate this quotient. And we get y squared. On the numerator, we differentiate x, the derivative of x equals to 1. And we keep the y unchanged and subtracting, and x is unchanged, and it differentiates y with respect to x. So the left-hand side is done, on differentiation. Right-hand side stay the same, right? So this step is optional, it's up to you. And now let's organize it. Okay, 1 times y is y, x times dy dx. I can remove the dot. We can even remove this dot. Okay, we can remove that dot. It doesn't hurt, but have it there, it's okay. Okay, and what we need to solve for dy dx to show up in these two terms. So we have to do some algebraic. So the rest of it is algebraic manipulation. Okay, the goal is to solve for dy dx. One of the ways to do it is that we're going to multiply both sides by y squared. Okay, so I can multiply both sides by y squared. Okay, so multiply y squared on here, and we multiply y squared and we multiply y squared. Okay, we can remove the dot. 1 times y squared is just y squared, and we can just remove this. Whoops. Come back, right? Just remove the y squared from that expression. Okay, after. But here you can see we must have a parentheses. Okay, so from this step, we multiply both sides by y squared, and we got this. And next, we're going to distribute e to the power of x over y to this term and to next term, and that way we're going to separate. Okay, so we do the multiplication, distribution, so y times e to the power of x over y, no need for the dot, subtracting negative x times dy dx multiply e to the power of x over y. So we get x multiply e to the power of x over y, x over y, and multiply dy dx. So now we're ready to move the terms around. Okay, so we're going to subtract. Oh, here is subtracting, so we're going to add this term on both sides, right? So we're adding this term on both sides, adding that term on both sides, and of course also adding the same term on the other side. Okay, so adding. And after this adding, right? And on the right-hand side, this term is, these two combine into 0. On the left-hand side, we have y squared, subtracting x times that, right? And of course, we're in factored form. So we write it that way. Okay, so that's already factored. Okay, and after this is done, your reader really don't need to see this. Okay, and you can remove that. At the same time, we're going to subtract this term on both sides. Okay, so we're going to subtract that on both sides. Okay, so subtracting on both sides. There. Okay, I don't know how that dot get there. Okay, so subtracting the same thing on both sides, adding the same thing on both sides. On the right-hand side, we're going to have y squared, subtracting this piece. There. Okay. But when you show your work, you don't really need to show this line. You don't need to show that line. You may like to keep it just on the scratch paper. So I'm going to remove it from here. But that's what has been done. Okay. So now we're just one step away from finding dy dx equal to the whole of the denominator is divided into the whole of the right-hand side. Divide into the whole of the right-hand side. And that can be considered done. However, for those of you who realize this is odd number questions and you look up the answer in the back of the book, you may be surprised that the answer in the back of the book probably is not the same as this one. Why is that? Well, most likely the textbook has applied this relationship into, which is the original equation, into this final answer. In other words, e to the power x over y will be replaced by x minus y, which will cause the following. Okay, so replacing e to the power x over y by x minus y. So that whole piece is replaced by x minus y. And this piece is also replaced by x minus y. So this will be, it looks like it's a simpler expression. And then you may like to distribute it and maybe try to even reduce it. Let's see if we can reduce it. So we got y squared minus xy plus y squared. That's on top. We get 2y squared, right? So that becomes 2 times y squared. In the denominator, we have y squared subtracting x squared and the plus x times y. Okay. And I don't think we can factor this easily or find any common factors, but this is done. In conclusion, your answer could be either this one. Okay, I think in most cases, most likely in this case, I would consider this as the final answer. Or some of you who get to this part, okay? If some of you get to this part and showing the final answer as the latter one, that will be even better. So some additional credit may be awarded to the student who does that. But, either way is acceptable. Okay. So let's look at 17. 17 is arctangent of x squared of y equals to x plus x multiply y squared. Okay. So that's, of course, we want to find dy dx. Okay, we view y is the function of x, so we're going to differentiate in this equation implicitly. Okay, so now we got differentiate with respect to x on both sides. You can see from the left-hand side, we're going to do chain rule and also the product rule. And in product rule, there's chain rule. Okay, on the other side, derivative and of x plus xy squared. So we got all of these set up. Chain rule. Okay, so derivative with respect to du, arctangent u, and obviously u is x squared multiplied by y, right? And then derivative with respect to u dx. And u is the whole in the parentheses right here. There, right? On the right-hand side, we got the sum of differentiation and the product. And the derivative of x equals to 1. The derivative of this product, right, would be equals to, we're going to write it in 2 terms. The derivative of x is 1 multiply y squared plus, right, derivative of y squared. Derivative of y squared, we're going to use the chain rule again, right? It's going to be 2y dy dx. And next step, we're going to finish up, okay? You could, combine these two steps together. So on this step, it's going to be 1 over 1 plus u squared, right? By this time, so that's a derivative of arctangent u with respect to u. And by this time, you can replace u by its equal. There. Okay? And derivative of this product. This product, of course, we're going to get another parentheses. You can use a bracket if you want. The derivative of x is 2x and multiply by y plus x squared and the derivative of y with respect to x. So now the whole of the left-hand side is done, the whole of the right-hand side is done. And now we need to manage to bring dy dx together. Okay, so on the next step, we're gonna just organize the term a little bit. And we can remove this parentheses now, 1 times that, right? And here we can write 2 times xy. And what do we do, right? One of the things you can do is try to, of course, here you can write it as x to the power 4 multiply y squared. Okay, so this is x to the power 4 times y squared. Okay. The next step, okay, there are multiple ways to do it, but the way I would recommend to do is to get rid of the denominator by multiplying this on both sides. We're going to multiply on both sides this term. So you can see that will, and this will make 1, right? And this term, this multiplier, will be multiplied to the other side as well. So it's going to multiply that guy and multiply on this piece. Wait, I'm going to copy. Okay, copy and paste, multiply that. And I'm going to make this larger. Okay, and multiply that and multiply that. Okay, this is a little bit too long, so let me make it smaller fonts. So that way we can get rid of this part with the denominator. And at this time, as you can see, this is 1 times that, and we can remove it. So this is remove the parentheses. And here we got y squared times that over that. But now we just want to bring dy dx together. So we got this. Okay. Focus on the dy dx, right? So bring these two terms together. Move everything, move this term to the left-hand side. So we're subtracting that term, okay, and subtracting that term, right? You can see the left-hand side would equals to x squared, oops, x squared, subtracting the whole of these, right, in parentheses or in bracket, and then dy dx. So this part, that makes 0, and this term we move to the other side, and subtract 2xy. Okay, so I'm going to skip that part, and we, as usual, you don't need to show this to your reader. So the whole of the right-hand side without dy dx is going to be subtracting 2 times xy. Okay, so you want to double check on this step, right? These doesn't have dy dx, so they stay on the right-hand side. And this one doesn't have dy dx, it's moved from left-hand side to the right-hand side. And this term has dy dx and moved to the left side. Okay, so next step, we're going to divide the whole of the bracket. So dy dx equals to the whole of the bracket. The whole of the bracket divided into the whole of the right-hand side. All right, the bracket can be removed. The bracket can be removed. Okay, so make it larger. Let's see if there's any room we can reduce it. Is there any room we can reduce this? The original equation is like that, right? So there's no more arctangent here, so we can't really remove any arctangent. And you could try to like open up the parentheses. Okay, so let's try that. Okay, to see if we can combine any more like terms. Okay, so on the numerator we have that stays, right? Copy and paste, and y squared times inside the parentheses, so we got plus y squared plus x raised to the power 4 multiply y raised to the power 4, right? Minus 2 times xy. Do we have any like terms to combine? And I don't think so. The denominator equals to x squared, subtracting 2xy minus 2 times x raised to the power 5. Okay, y raised to the power 3. Besides, we can factor out the x in the denominator, and we cannot get a common factor from the top. We cannot reduce this any further. So this piece is going to be the final answer. And you don't even need to do this, because once you realize there's no room to reduce, you can just leave it as is. All right. So now let's look at another one. Okay, this one, it would be number 19 that we have sine and cosine on both sides. Okay, so we have sine of x times y equals to cosine of x plus y. Okay, and once again, we wanted dy dx. Okay, so we differentiate on both sides. Derivative. Okay. Left-hand side, chain rule, the derivative of sine of u is x times y. Let's try without introducing any variable explicitly, right? So we're gonna have a cosine, cosine xy, and then we're gonna differentiate the derivative of x times y. The derivative of x is 1 times y plus x multiply dy dx. On the other side, the derivative of cosine is negative sine of x plus y. And then we're going to differentiate x plus y. That's going to be 1 plus dy dx. Right? So then we're going to bring dy dx together, which we have on both sides. Remove that, right? So distribute cosine xy. So we're going to multiply that guy, right? And remove the bracket, and we don't need the dot. Okay, so that was distributing cosine x times y into each one of the two terms in the bracket. And do the same on the right-hand side. Okay, so times 1. Okay, so that times 1 times the other one, right? And times 1, we can get rid of it. We don't need the bracket. And plus minus, that's minus. And we can drop the dot. So now dy dx is about to be brought together. So let's bring them together. Okay, so on the left-hand side, we're going to have the dy dx factored out. So x times cosine x times y, adding sine of x plus y. That's the left-hand side in the bracket. Right-hand side, subtracting that on both sides. So subtracting. And that was on the on the right-hand side, so we keep it that way. And then we're going to divide the whole of the bracket on both sides, So the whole of the right-hand side goes to the numerator. The whole of the bracket goes to the denominator. Any room to reduce? Any room to reduce? Well, on this equation, we have sine. On the given equation, we have sine x times y. Do we have a sine x times y available here? The answer is no. We don't have a sine x times y. Do we have a cosine x plus y? We don't have that either. So this will be the final answer. Okay. And also, when you try to substitute, it doesn't produce anything simpler. Then you can just leave it out. Okay. All right. I think we might have just a little extra time to do. I think I'm going to do number 11. Okay. Number 11 goes like if y multiply cosine x equals to x squared plus y squared. Okay. And once again, we want a dy dx. Dy dx. Implicit differentiation. Okay. Derivative with respect to x, y times cosine x. We're going to apply product rule. On the other side, we're going to apply the rule of the sum of derivative as well as chain rule. So that's on the right-hand side. On the left-hand side, right, we, differentiating y, so we get cosine x, and then multiply x plus y times derivative of cosine x is negative sine x. The product rule is done. On the right-hand side, the derivative of x squared with respect to x, that's going to be 2x. The derivative of y squared with respect to x, that's going to be 2y multiply dy dx. Oops. Sorry. Okay, so that's 2y times dy dx. There. Organize the term just a little bit. Okay, so this is a negative. So we can bring that negative sign in the front. And drop this dot, subtracting that on both sides. So we're gonna end up with cosine x subtracting 2y inside parentheses dy dx equals to, on the right-hand side, 2x, and we're adding this piece on both sides, so we get y times sine x. Okay, double check this step. Maybe work on your scratch paper, okay, or pause to work it out. So in the end, the dy dx is equals to the whole of the parentheses in the denominator and the whole of the right-hand side in the numerator. And that's it. That's all. But last but not least, and I think we can do number 9. I hope I can make the 30 minutes cut. Last but not least, okay, so we get x squared, okay, and x plus y equals to y squared plus 1. And once again, we wanted dy dx. Okay, this is going to be the last. Derivative on both sides. So obviously it's going to be quotient rule, right? On the other side, derivative with respect to x on y squared. Parentheses is needed. On the left-hand side, we're going to apply the quotient rule. Quotient rule is going to be having x plus y squared. Numerator, right? Derivative of x squared is 2x. Multiply x times y, the numerator. Subtracting x squared stays the same, and derivative of x plus y, and that's going, oops, the derivative of 1 plus dy dx equal to, on the right hand side, the derivative 1 is 0, derivative y squared with respect to x, that's going to be 2y dy dx. Okay, we get dy dx on both sides, so we need to do something about it. Well, to get rid of the denominator, multiply x plus y squared on both sides. On the left-hand side, the denominator is reduced. The left-hand side will be left with this guy. On the right-hand side, it's going to be 2y times x plus y squared. And then, right, so this piece multiply both sides, we have 2y times that, dy dx. dy dx. And then we're going to distribute this x squared, negative x squared, inside the parentheses. Okay, we can remove this. And you can distribute that, but don't need to right now. So negative x squared times 1, we get negative x squared, right? And negative x squared times dy dx, that's going to be minus x squared. And now dy dx here, dy dx here, include, then we should add this term on both sides. Okay, so we're going to add this term on both sides. Adding that term on both sides. Right, so this side is only left with term without dy dx. So on the left-hand side, we have this piece. On the right-hand side, we're going to have dy dx outside, factored out. And inside the parentheses is going to be that piece, adding x squared. Okay. Do we need to FOIL all of that stuff? I don't I don't see the necessity. Just leave it there for now, okay? Maybe use a bracket. Okay, sometime in this case, when you have two layers and you want the outer layer to be bracketed, it makes it easier to identify. And last but not least, we got dy dx equals to, okay, the left-hand side is going to be the numerator. The whole of the bracket will go down to the numerator, to the denominator. Look, we can remove the bracket. And now, I think we're done to a certain degree. If you want to see if there's a possibility for a simpler expression, you may want to bring back up the original equation. Okay, the original equation, this is actually a good opportunity to practice with algebra. Okay, because x squared over x plus y, right? On this piece, you have x squared. So you might want to, try something on the side. Okay, so for example, I'm going to do this. Okay, I haven't decided whether I'm going to go further to apply. So I'm going to, on my scratch paper, okay, I'm just going to try things out. I'm going to take this piece and play with it, applying this, right? Obviously, x squared is equal to, if I multiply both sides by x plus y, right? So x squared is equals to y squared plus 1. Okay. Multiply x plus y. Right? Does that produce anything? Well, just try it. Just try it. Okay. So on the top, the top is going to be that piece, right? And the bottom is going to be that piece. Okay, the bottom. Okay, just try things out. Okay. This is what I'm going to do. I'm going to expand. Okay, just multiply this out. There we go. Because if I do 2x squared, then I reduce it, I get 2x, get x squared times 2xy, right? On the bottom, I'm going to expand, and I got this. All right. Is there anything I can do if I replace x squared by this piece, right? Replace x squared by that piece to see what I get, expanding. Not much better, not much better. So I decided after all of these, I'm only going to simplify the top into x squared plus 2xy, right? By distributing. And the denominator, I'm going to keep it as is. Boom. Okay, so these take some experiment on the scratch paper. Sometimes it's totally not worth it to continue. And sometimes you may get something simpler. However, okay, in most of our questions on the quizzes or exams, I would be happy with this answer. If you can get to this place or that place, you will get most of the points, because most of the points are at the calculus part. The algebra part carries some weight. So it's the calculus part and algebra part that both counts. So in terms of the last step simplification, I will observe and determine how many points I will give when overall of the performance of the class is considered. Okay, so that's all for this lesson. Thank you for watching.